I will introduce about array. So what is an array? Array is a sequence of consecutive data addresses within memory. Each item is accessed using an index. The total number of items is the array size. Means that the size of the array is how many, or the sum of the number of items that we want to save. So the array in MIPS is accessed using base address plus offset. So the offset is the index times the size of each element. MIPS uses instructions like load word and store word to load or store array elements. In the array indexing, the array is located in a processor's main memory beginning at the base address 1001.000, and then the base address indicates the location of the first element in the array, which is index 0. So we always start at index 0, and then we can declare the array as any declaration name in a like a variable. So and then they will consider as the first one, the first index is the first element, and also can be considered as the base address. In MIPS assembly, the array is allocated in the dot data, okay, dot data segment, using a label. In this case, the example is numbers, okay, to reference its base address. In this case, the variable numbers here or the array numbers here indicate the location, the location or the base address to that array. And then we declare with the data type dot word, means that each of these value will be stored one word, one word, one word. Okay. And then to load the base address, we need to access an array element. First is that you need to load the base address, load it into a register. Okay, so that register will become the base register. Okay, we'll call it as a base register. Solely to store the base address. This using LUI. Okay, you need to store the 1001, okay, and then 0000, okay, as the base address inside the S0. So you need the LUI and or immediate instructions. Then you can store the full 32-bit address. After that, okay, you can access the data, okay, by first maybe you store data, right, store a value. So the assignment is performed with a store word, okay, instruction using a base plus offset addressing. Here you want to save index 3 with the value 100. Okay, so in order to calculate the offset, the immediate that you need to jump into, how many bytes that we need to calculate the effective address. Now we calculate the offset as index times 4. Index is referring to the array index. So here the array index is 3, and then we times 4 because of each integers here are stored as word. So one word is 4 bytes. Okay, so 4 times 3 is equal to 12. Right? So ADDI T0 100. Okay, so here is that we want to store value 100, okay, inside the T0. So we need to correct this because this should be register 0 only. Alright, so remove the T0 here lah. Okay, now now 100 is loaded inside the T0, and then this T0 will be stored into the effective address in the base address 1001.0000 plus 12. Okay, so here the value of 100 is stored at address 1001.000 plus 12, or C, 0xC in hexadecimal. Alright. Example 8. The code uses in this example, the code uses a for loop to add up all 5 elements of the array called numbers, okay, which start at address 1001,000. To find each element, you calculate its address by multiplying its index by 4, because each element, this one is considered as one word. So one element is 4 bytes. In MIPS assembly, you can multiply by 4 easily by shifting the index left by 2 bits. So these methods works for arrays of any size. Okay, in the C++, okay, we have array of numbers 5 with a value 10, 20, 30, 40, 50, and then with a sum of 0. And then from I is equal to 0, and then I is less than 5, I plus plus as the counter. So we will add the sum plus numbers, okay, with an index I. Okay. For the declaration of integer number 5, okay, we will declare under dot data with the numbers dot word 10, 20, 30, 40, and 50. So this is equivalent to the C++ coding like this, okay, on the hashtag here that I have copied. And then on the text space, okay, I will start with the loading the numbers, okay, the address or the base address. Load base address of numbers array into a register. So in this case, we use A0. Okay, you can use A0 to load 10010000. Okay, and then start with initialize I is equal to 0, and then sum is equal to 0. So we will use T1 as I, T2 as a sum. Okay, so T1 initialize as 00, and then ADDI T2 register 0 and 0. And then we will start with the loop. If I is less than 5, okay, we will continue, else break. So means that for the instruction here, it must be less than 5. Okay, less than 5. Then we will do the sum. Okay, else means that I is equal to 5. Okay, means that I contain 5. 5 is not less than 5. Then we can go to break, right? So set less than immediate. If T1, which is I, is less than 5, so the result will be stored inside T7. So T7 will become the flag register. So T7 will become 1 if I is less than 5. Next, we compare the T7. Is it equal to 0? Okay, if it's true, means that I is equal to 5. Okay, so they will branch to done. Okay, now this is false. So T0 is not equal to 0. So we will continue with the next line. So shift left logical T3, T1, and T2. T1 is I. Okay, we multiple by 4. Okay, and then put it inside the T3. Okay, and then we add the content of A0 with 4. Okay, I times 4. So, and then, okay, we add it and store it inside T0. And then load. Okay, load the base address plus with offset, the target address. Okay, and then use the immediate 0 because we already added the offset, right? So we can just keep on using the 0 here. Okay, now if we have the target address, and then we will load the data inside the T4. After that, add the sum T2 plus T4, and then store back the result into T2. Okay, and then don't forget I plus plus. So T1 plus 1, and then store back inside T1, and then jump loop. So we repeat this loop until I is equal to 5. So is 5 less than 5? It will become 0. T7 will become 0. Now BEQ T7 is 0 is equal to 0. Now we will branch to done. So when we branch to done, then we can exit. Okay, so this is how the array can be done. Okay, the only difference is that we are using the loop, same as previous times, but we added load and store. Okay, so you can do the store word also, Also, you can do the load word also inside the loop. That's all. Thank you.